All right. Good morning, evening, night, afternoon, whatever it is for you guys out there. Today we're gonna do the last video of the year. Kind of a sad day for me. Combinations. Now combinations takes permutations a step further. Permutations, order matters. Combinations, order does not matter. Okay. Example where order doesn't matter. I choose the first 4 students into my room. I'm gonna give them $100 for the math convention. I know everybody's super excited to be running there. Just like permutations, combinations, we don't denote it as NCR or CNR. N is the number of elements. R is the number of elements in the set. So, in other words, if we had 10 people, how many different ways can I put 4 people at the head table? Okay, I don't care where they sit at the head table. I just want 4 of them there. Now, the combination equation. This changes just slightly. That combination equation is just simply NCR equals n factorial divided by n minus r factorial times r factorial. Okay, like I said, this changes just slightly. So we have 7 factorial 5, 7 combination 5, 7 combination 5. So I know this is, gotta switch to the marker, 7 factorial over 7 minus 5 factorial times 5 factorial. And like I said yesterday, I'd try to get whatever cancels. So I know the 5 down will cancel. So I know I'm left with 7 times 6 on the top. On the bottom, that 5 factorial cancels. So I'm left with 7 minus 5, which is 2 factorial, which is just 2. I could do this. 7 times 6 is 42. So I get 21. Again, if you have one of my calculators like I have at school, we can type this in our calculator. 7, do PRB, then go over to combinations, and then do 5. I get 21. So now I'm going to do the same thing. 4 factorial. 4 minus 2 factorial times 2 factorial. So I'm left with 4 times 3 on the top, 2 factorial on the bottom. Gives me 12 over 2, which is 6. I'm just double checking my answer for some reason. Yeah, that's right. I don't know what I was thinking. Some days I amaze myself what pops up into my head. Last one here, I've got 8 factorial, 8 minus 6 factorial, 6 factorial. Again, that 6 factorial cancels out, so I'm left with 8 times 7 on the top. On the bottom, I'm left with 2 factorial. I get 56 over 2. I get 28. Now, when I do this next one, again, this is just like yesterday. Is it possible to have more people than what I had? So can I take 7 of my best friends and choose 8 of them to go to the movie? I can't. So this is just 0. Anytime that element is bigger than the set, it doesn't work out. Just doesn't work. And how many ways can a coach choose 3 swimmers from among 5 swimmers? So I just want to know, well, 5 combination 3. So that's 5 factorial over 5 minus 3 factorial, 3 factorial. That 3 factorial cancel. So I get 5 minus 4 over 2 factorial, 20 over 2, which is 10. Simple as that. 6 friends want to play enough games of chess to be sure everyone plays everyone else. How many games will they have to play? Well, so I'm doing 6 combinations of 2. Because you have 2 people play chess at a time. So I get 6 factorial over 6 minus 2 factorial times 2 factorial. Now, this is where I'm going to do things slightly different. That 4 factorial will make so I have less work. So I'm going to cancel that 4 factorial because this is just simply 6 times 5 times 4 factorial over 4 factorial times 2 factorial. They cancel. I'm left with 6 times 5 over 2 factorial, which is 30 over 2. So I know I have to have 15 games to get everybody play, or have all my friends play everybody else. Okay. I'm going to come back here for a second. What happens if I had 8 combination 8? So I had 8 factorial over 8 minus 8 factorial times 8 factorial. 8 factorials cancel, so I got 1. Yeah, I don't need that little mark there. Over 0 factorial. We know 0 factorial is 1. I don't know why I put a 0 there. 1. And that makes sense. If I had 8 friends and I wanted to choose 8 friends to go to the movie, I'm going to choose them all. They all get to go. Let's do this. Something I maybe should have talked about yesterday is 8 permutations 8. 8 permutations 8. How many people think I should get 1? Well, this is different. Combination just says, hey, I want to choose 8 of my 8 friends. I want to choose 8 of them to go with. Now, permutations is, hey, of my 8 friends, I want to decide who gets a first seat, who gets a second seat, who gets a third seat. So that's 8 factorial, or 8 minus 8 factorial. 8 factorial over 0 factorial. I do this 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Gives me 4,320. 0 factorial is 1. So there's 40,320 different ways to have my friends sit in the seats 1 through 8. Okay? You don't have to worry about deciding between combinations, permutations today. You guys are just working on combinations. Last video of the year. Last video for you guys for the year. Like I said earlier, this sucks. I wish I was seeing you guys in person right now, instead of having to do it this way. I miss you guys all. Can't wait till whenever I see you guys. Expect a dumb, nerdy math joke. I'm trying to hide my emotions that I miss you guys. You guys got this Google form for your assignment. We will talk to you later.